Welcome back. Today is the 11th of October. This is CSC220 Intro to Cybersecurity. We gave you class time on Monday to engage and complete the 2.1 assignment, and then to get started on the 2.2 solution. And what I wanted to do was to take some time to walk through some of the highlights of the 2.1 assignment, and then to work step by step through the expectations for the solution. And what we want you to do is to make quick work of this to finish your review of the study guide, right? To complete your review of the slides that are in the resources and reference folder. I think must be in the references here. Module slides, chapter 3 and 4, although your author, the textbook authors, call it module 3 and 4. We're going to call it chapter 3 and 4 of the book. Notes and diagrams, right? You have an addendum and, you have an addendum supplemental. Now, you may or may not have dug into these, but remember that anything in the references folder is important to know well. And in the addendum, you're going to see things that are basically essential to know, like key terms, right? So these are key terms in the order of use in the chapter. And so these supplement the study guide. So if you don't see it in the study guide, but you see it here, it's important to know these, right? Everybody got that?
Yeah.
So the 5 governance processes, if you're going by the international standard, remember 27,000 is the cybersecurity series, and it's 27,014, which was published in 2013. I don't know if we explained this to you, but for the ISO standards, when you see a colon followed by a 4-digit year, that's the year that the standard was published. So that would be the latest one. And it could be that the 27014 it actually has a newer version, and that happens sometimes. Now with the NIST, National Institute of Standards and Technology, Special Publications Series 800, when you get like 800-53, which have to do with security controls. Once again, 800-53 have to do with security controls. When you have newer versions of the federal, our US federal NIST guidelines and standards, right? Those, you'll know there are new versions by the release number, R number. So it would be R2, R3, R4. I'd kind of like to know what version we're on with NIST Special Publication or SP 800-53. And as soon as we get a screen here, we'll query Google and see what comes up. So NIST 800-53. Oh, it looks like we were in that same territory. Oh, revision 5, right? So when you look, they're working on revision 5, which would be the then you can download and get copies of this. When you see the R5, does everybody see R5 here?
Yeah. Yep.
So that's 53 dash, that's dash 53 R5, that stands for release 5. It's in its 5th release, which is really pretty amazing when you think about it. See, this is dated like around the around July of 2023, right? So one of the things they did was they mapped the 53 over to 27,001. This is actually a very handy reference. So our US federal reference is 800-53, and if you want the international standard, it's 27,001. And there's criteria in the 27,001 international standard that map directly to the federal standard. And this is one thing that you find is that sometimes the international standard is ahead, sometimes the European standard is ahead. Europeans have a different cybersecurity standard that they operate by, but in order to be safe, they often operate off of the ISO standards because that's, you know, that covers everything, right? Any questions about that specific information?
Wait. I thought that the Europeans use the ISO.
They do.
Which standard do they use? Oh, okay, so they
do. Now.
Oh, but you're saying that they use the NIST as well, just to.
No.
No. Okay.
No, it's that they have a different legal. All right. So I should back the truck up. The standard is ISO 27,000 series. But European Union data protection, GDPR, General Data Protection Requirements. I think that's what it stands for. This would be the European version of cyber law. We have HIPAA, right? So we have a law, we have standards that NIST puts out, and these are guidelines and standards for how to work best practices and such. But there are many US federal laws that are mandates that require cybersecurity protections, and HIPAA is one of those. And actually, we're going to spend some more time digging into that aspect of cybersecurity in greater depth in a later module. But this is one aspect of risk management that's really important to understand. And I'm not so sure that it's explicitly stated yet in this module, but it could be something that nips on your heels a bit. Let me explain further. In Europe, in the European Union, you have the GDPR. In the United States of America, you have the Patriot Act. You have HIPAA. You have the Computer Fraud and Abuse Act. You have electronic privacy. There are all sorts of federal laws that guarantee certain standards are met, and in some cases, if they aren't, it's under penalty of law. When I say under penalty of law, I mean a felony prison sentence, like 5 years mandatory prison sentence with $50,000 fine per occurrence. And you know, if somebody's doing some hacking and they get hundreds of files, then that could be considered hundreds of occurrences, right? Or if they hack a dozen systems on the same network, that could be considered, depending on the jurisdiction and how the prosecution wants to make a point. What I'm telling you is that risk management, one of the dynamics of risk management for an organization is understanding how their liability and the penalties, the civil penalties, the criminal penalties can add up if certain cybersecurity standards are not met. And then when it comes to risk management, you have other weirdness in the mix. Like there is an international PCI DSS, right? So PCI DSS is an international security standard that has to do with payment cards. PCI, Payment Card International. So it's an international association of financial institutions. And this is a fancy way of saying credit cards, okay? Now, guess which government passes laws that PCI enforces? Would you care to guess?
US government?
It's a trick question. This is a professional association in the financial industry. It has to do with credit cards, and it's global. And there are no governments affiliated with PCI. PCI basically enforces a set of international industry standards in the financial industry when it comes to credit cards. And if you don't protect the network that a credit card machine is connected to, PCI can come in and they can shut down your credit card. They can basically say, you're screwing up our payment card standards. And so, well, your cards just won't work anywhere in the world. You don't get to do this because we've taken away the golden key. And that's a reality. PCI is a reality. Now, they consider that certain standards and guidelines like ISO 27000 series and the NIST, Special Publication 800 series, they reference these things, but nobody in PCI required the governments to write laws to protect PCI or vice versa. PCI is independent. In a sense, it's kind of like the ISO version for credit cards. And if you screw this up, you don't get to use credit cards. And I've seen that happen. I have actually seen that happen to people. And it's not pretty because all of a sudden your identity is associated with which bank accounts? Oh, it doesn't matter. Go to any bank, go to any credit card company. As soon as they know it's you, sorry, you don't get a credit card because everybody knows. All over the world, right? So what's the risk? The risk is if you operate with credit cards and you depend on credit cards and you get shut down by PCI because you didn't meet their standards, you're screwed. You have to find another way to work your financial transactions in order to keep your business going. Now there was a question. I heard somebody saying something.
Yeah, I was just going to ask: is PCI as an international organization, is it similar to the World Health Organization? Except I guess the World Health Organization is more tethered to governments, right?
Well, the World Health Organization is aligned with the United Nations.
Oh, yeah, okay.
Yeah, and so you could consider PCI as sort of like the United Nations of banks and financial institutions, in a manner of speaking, right?
Okay, so it brings those institutions together.
Well,
in alignment.
It's an industry association that standardizes how credit cards are used so that, I mean, you know this, you take your credit card out, you use it in Miami, you use it here, you go down island, you can use your credit cards anywhere. How is that possible? It's possible because of PCI. Even though the cyber laws differ from country to country, screw this up and it doesn't matter which country you're in, you're not using a card. And that's because the financial industry all came together and said, you know what, if somebody screws up these cards, we're all messed up. Which is why fraud with credit cards that crosses international boundaries is still effectively managed and shut down. I mean, sometimes they get ahead of the industry, and so the bad guys win, or they get, they have their good days and their bad days. But basically, it's this organization that ensures. I actually sat next to a guy on a plane who was flying into the Virgin Islands so he could fix somebody's credit card machine because they messed up their PCI audit and they did not pass. And he had to fix their machine to make sure it was secured so that they could use their credit cards. So he was flying in from the States to St. Thomas to fix somebody's junk. And that's a true story. That happened a couple of years ago. Very mind-blowing. Thank you for asking that. Okay, so just remember when you see addendums and you see addendum supplementals, oh, there's even more stuff. So there's layers of information, okay? Now, these are really important things. We did mention things about an organization and how they're structured with an org chart, and this is just another view, right? And this is one thing in the supplemental that I want to call out. Education, awareness, and training programs, or as your author likes to call them, SETA programs, they are one of the most cost-effective and beneficial things to do in cybersecurity, yet, ironically, they are the ones you would think the cheaper things to do would actually be more attractive. No, they just take time and they're a nuisance, so nobody does them. And that's the problem, even though they're less expensive overall. So what does stupid cost you? Oh, you'd be amazed, right? Security policies are the least expensive control to implement, but the most difficult to implement effectively. Now, when I say security policies, I'm talking about like operational policies that people have to obey and they go to training. I'm not talking about policies that are implemented on systems. Now, we do have another use of the word security policy, which gets us back to our assignment. There is a thing called a system security policy, and or it's a group security policy. Let me explain. So this is a version of, and I'm on the right system now. So I go into here, system. Right. Everybody with me? Can everyone see what version of Windows I'm working with? What version am I on? Edition. What edition of Windows? I'm on version 10, and I'm using the professional edition. Everybody see that?
Yeah.
Okay. Now, if you have the home edition, this doesn't work. But if you go into here and you start to type GP edit. Oh yeah. Edit group policy. And people are going to say, what the hell is that? Well, these are system policies. That's something that's a little different. And it has to do with Microsoft. So this is a vendor context. And it's different from like information security policies that the staff has to follow when they're using electronic payments on a website, right? If you have a corporate version of an operating system, you can set up system policies or group policies, and in this case, it's called a local group policy. On the computer, I can set up things that have to do with accounts, like what's the lockout policy on this computer? How many times do I get to attempt a login before I'm locked out? And I can set that on the computer side of things, or I can set it on the user side of things. Okay, so one of the important things to understand is that a computer policy, when you're talking about Windows corporate versions or editions of the operating system, that's a technical security control. That's not to be confused with an operational policy that people use in the way they flow their work, you know, the way they do their workflow, process their business, right? If you apply it to the user, right? Now, sometimes you don't have the same settings. You can only apply it to the computer, or you can only apply it to the user. There are some settings you can use or set. And when you get into this, it's actually pretty interesting. So if I go into password policy, Can everybody see this?
Yeah.
So I have
Yep.
enforced password history. So it remembers the last two passwords. Yeah. The maximum password age is 120, right? The minimum password age, the minimum password length, the complexity, right? When we say complexity, if it's enabled, it has to have upper and lower case, numbers, and special characters. You probably wondered, where are these settings and how do you work them? And there are some really fascinating security policies, group policies that you can enforce. Now, in an Active Directory setting, in an enterprise setting where you have domain controllers and you have PCs that belong to a domain, these can be set on the domain level. Instead of being a local computer policy, it's a domain level computer policy, which is really cool because you could say, okay, everyone in UVI, you have to have complex passwords that are at least 9 characters long, and you can't repeat the same password for the last 5 passwords that were used, right? And then when those systems reboot, those are enforced. So one of the things that is hard to understand is that a lot of the security controls are a 2-step process. For example, if you audit something, you enable auditing, but then you tell the auditing or logging, okay, what is it I'm looking at? What am I going to log? Logging is enabled, but I haven't found a target for it. If I don't configure what's going to be audited after I enable auditing, my system logs won't watch what's going on. The same thing is true here. I can create a policy that says, oh, users at St. Thomas, they look at this screen when they log in. Users on St. Croix look at this screen when they log in. Everybody has the same desktop. You can only work from the hours of 9 to 5. You can get incredibly elegant with these controls. But it doesn't matter if you don't take that group policy and then enforce it and apply it to an to a component or container of the Active Directory. So in that organization in uvi.edu, we have different organizational units like staff and faculty and administration and so on. And if you don't take the policy and apply it to one of those, it doesn't do a thing. And a lot of times that's where security controls just don't work very well. So that's something I thought would be worth sharing with you. Now, the context we just covered is important to understand because when you work this, policies versus policies, that's part of what we were doing here. We were explaining that you have like the rules of an organization. It is our policy that nobody puts your password on sticky notes and puts them on the monitor. That's not a technical policy. That's not a group security policy. That's a human policy. And it takes human beings to enforce that. We have to walk around and look at everybody's monitor. And we walk into their office physically and we look to see, are there sticky notes under the keyboard, under the mouse pad, in the desk drawer? Hell, on the monitor. Let me say that again. There are people who put sticky notes with their password on the flippin' monitor. That's a different kind of policy, but it's a very important one, right? So what we wanted you to do was to walk through the handy video and then watch this longer video on risk management and cybersecurity, right? And I am really hoping that oh my gosh. What'd you think of this? Any comments? Was it informative? Did you learn anything?
Yeah, I mean, it reinforced a lot of the ideas from Module 4 about risk management.
Right.
And it kind of made more sense of the calculations that they were doing at the end of the chapter.
Yes.
Calculating.
Yeah, that part of it I found incredibly helpful. I mean, I could try to explain it, and I do sometimes each year, but then every now and then you find a video that makes better sense. Now here, in number 1, it says, give the 3 types of policies in cybersecurity from last week. We're talking about the publisher's slides where there was a system-specific policy versus, right? So you have those 3 different types of policies. It's in the definitions. It's listed in the definitions. And which type do you think local policies in Windows 10 or Windows 11 represent? So what we're asking you to do is to consider the stuff in the slides from last week. And then now that you've learned about these things, what kind of policy are these technically, right? Well, here's your hint. You won't find this in Linux or on a Mac. You only find this in a Windows system, right? Okay. So you're tasked with reducing the risk of login exploits. You must draft a short but effective policy to enforce the use of 2-factor authentication by all online users served by your organization. Does everybody know what 2-factor authentication is? PIN codes and stuff?
Yeah.
Did we have an assignment with 2-factor yet already?
No, not yet.
Okay. Well, it's coming. When we get into the next module, we start talking about identification. When we start talking about identification, we'll be talking about 2-factor authentication, verification of your identity, right? Okay, let's shift a gear. I wanted to segue into the solution. So the solution provides capture samples. These are my examples. Please do not include them in your own submission. You might ask me why I'm stating that. Go ahead, somebody ask me why I have to state that each year. Please. Somebody ask. Do I have a volunteer to ask? Professor Kentop, why do you have to make that statement every year?
Why do you have to make that statement, Professor?
Thank you, sir. I have to make that statement because in this cybersecurity class, one of the students tried to hack the submission by using my own capture samples and doctoring up the image a little bit to try to fake it. And it really didn't work because there are other things in files that are like a smoking gun. Have you ever heard of something called metadata?
Yeah.
Metadata. Yeah. Yeah. So when you go into a file, right? So if you haven't heard of metadata yet, let's give you a quick example. In my temp folder here, I have a file name and it's an ISO, or I have screenshots, right? Well, let's look at the one with screenshots. Okay. I'm looking at a screenshot. Yeah, so this actually happened while I was doing something and it triggered an infinite series on the screen. This is the new TV, right? And all of a sudden, wow, never ended, crashed the system. That was kind of weird, kind of freaky. Anyway, the point is, if I look at this picture and I go into the properties and I look at details, oh, there's extra information in here, right? Things like Things like who the owner is. Who the owner is. Now, if you could imagine somebody trying to use my samples, and passing it off on their own, but they didn't know to change that. That would be awkward, don't you think? When somebody's trying to tell you that it's their picture and you're like, dude, look. Is that your ID number for UBI? No, whose is it? Oh, it's mine, right? So that's the kind of thing we're talking about. That's why I mentioned it. Now, of course, have I ever mentioned this in our class before? Did I ever tell people, hey, you can look at my examples, but don't, in this cyber class, don't try to hack the submission for the cyber class. Is this the first time I've mentioned this in this class, or did I'm just curious. Does anyone recall?
I think so.
Yeah.
Huh? I think this might be the first time I've actually called it out as explicitly as I did. Okay, everybody sees we have 5 sections, yeah? Everyone? 5
Yeah,
sections? Okay, and what is the solution worth? 5 points. And what is your assessment worth? 5 points. Your solution is worth as much as what? The entire assessment. That's usually how it works, okay? You do have extra credit, yeah? And I wanted you to have good examples to go from, and high resolution or better resolution examples. But then I also wanted, it's really gonna make me work for it here. So context is really important. And it's the context here that we want to, reference out of the 3rd chapter. Now, again, I'm using the term chapter. When you go to your textbook, the authors call that module 3. Can everyone see this screen?
Yeah, we could see.
So one of the most important aspects of your ability to determine whether or not something is wrong, and this is something we may have already mentioned in our first module, is that the users are the ideal first line of defense against hackers, because the users know what's normal and what's off. Would that be a fair statement?
Yeah.
I mean, if you're using your system and normally it's pretty snappy and then all of a sudden it's really, really slow, the users know because they're on the front lines. They're touching it, they're seeing it, they're interacting with it, the users are. You're the most important cybersecurity method when it comes to controls and risk management and security measures, right? If there's a security program, a formal security program, everything starts with and ends with the user, and we call the user layer 8. Have I ever used layer 8 as a term in another class with you?
Yeah, you have.
Yeah, in other classes, we've talked about layer 8. Now, sometimes in tech lingo, we call the user the idiot, the ID10T, right? It's user error. There's a lot of, okay, so one of the nasty things about our industry is that tech support people can be unkind with users. And the simple truth is our users are our greatest asset. And this is where you are the greatest cyber tool of them all. So we can focus on the cool tools and the utilities, but the real truth is if you aren't square on this part right here, if you don't understand the context of your system operation, if you don't know the baseline of its performance, I have a certain baseline here. And when I look at Task Manager, I can look at the performance and I can see my CPU, as I'm conducting the class, I'm capturing a Zoom recording at the same time I'm pushing the Zoom recording out to you right now. And that's not just video, that's audio. I'm also multitasking, multiple tabs in a browser. I've got more than one application open. I have Paint open, I have Zoom open, I have Control Panel open, I have the systems configuration open, and yada yada. I have my group policy editor still open, right? So I know basically, depending on the load, what's normal. I also know that my Ethernet is going to put out, it's going to send about 0.5 megabyte per second under these circumstances. Can everybody see this? It says S560, R, and so on. So this is receiving, this is sending. And that's in kilobaud, right? So if I click on this, kilobaud per second, 500, 400, something like that. 0.5 meg per second is what I need for this to work right. Now, what would happen if I got on here and I saw I have 100 meg, let's say I have a gigabit Ethernet card, and let's say I have 100 megabits, not kilobits, 100 megabits, 200 times. 100 megabits per second is 200 times the upstream bandwidth going back out to the internet. Would anyone care to guess what's going on my machine if you ever see that? Have we mentioned the Mirai botnet, where we had 100 million zombies that took down the entire country of Great Britain a couple of years ago? Did we tell you about that?
No, I can't recall.
Okay, so a couple of months right before Hurricane Maria, and this is in August of 2017, some hackers figured out how to infect Wi-Fi routers that internet service providers put in people's houses, and smart TVs, and intelligent assistants, and connected devices, right? And security cameras. They found out a way to yoke or command or control all of those connected devices. Now, in that context, those are called zombies, right? Everybody, have you heard that term before?
Yeah.
Okay, so once we infect a device, now we control the device. And what we want to do is use that device along with millions of other devices. And if we can get them all to do the same thing at the same time, if I got 100 million of these guys, and they all pivot and they all put out 100 megabits per second, and we point it at, say, the DNS routers for the entire country of Great Britain. What is 100 megabits per second times 100 million? Well, here's 100 million. That's 100 million. And times 100, oh, that's right, megabytes is million. Times 100 million again. Okay. Oh, okay. So what is that? That's a gigabit, that's a terabit, that's a OMG, shut down the network. That's what Mirai botnet did. The Mirai botnet took 100 million zombies and they all decided to push 100 megs of upstream traffic. Now this was just digital trash, but they did it all at once. And what am I saying? I'm saying that this simple solution for this simple solution is a big deal. Because what we want you to understand is that there are certain things you're going to watch for on your system. Another thing that you can see that's a real big problem concerns hard disk activity. Can everybody see the disk activity here?
Yeah.
Okay, now considering what I'm doing, all the things I have open, I'm multitasking like a wild man right now in order to conduct this class. And I have how much? I mean, 5%, 6%. Have I broken double digits on my hard disk? No, I haven't. What do you think happens when ransomware hits and it's in the process of encrypting everything on the disk? What do you suppose happens to the disk activity? Right? Big time. It goes through the roof. In fact, the little blinky light starts to go crazy. Have we talked about kernel level exploits or rootkits? If you see that the disk activity is 0, but you see the blinky light for the hard drive activity going crazy like it's Christmas, you may have what's called a kernel level exploit or a rootkit. It's infected the very internals of the operating system, and it's masking the output right here. So it looks like, oh, I'm not doing anything on the hard disk, but the light is going like this, right? And that means you know that something really bad's happening with that hard drive, and it's not showing on the screen. And that is a matter of context or baseline. I want you to take your time to read this. Take quality time, right? Now, all right, so some of the videos are dated, but they're explicit. I want you to take each section, and I want you to do each section. And then if you run into some issues, this one's a good one. On Friday, we're going to show you how you catch a hacker who's covered his tracks. Because there are ways you can go in and they delete stuff to cover their trail, and then you can use other methods to go in there and you find out, oh goodness, yeah, there's somebody more in there. So we'll talk about regedit on Friday. I need you to be mostly finished with your solution. Mostly finished with your solution by the time we hit class on Friday. You're going to want to ask questions. You're going to want, this is hands-on, right? So you bring your system with you to class. You come to class physically if you can. And then we walk through, this is a workshop kind of thing. And what I want to do is help people with specific aspects of their solution. So if you run into snags or you can't finish something, you bring it to class on Friday, okay? What you don't want to do is show up on Friday and you haven't even touched this. Oh, and then over the weekend, you have to log your first attempt in the module. Oh, and the module assessment mentions a bunch of stuff about this solution. That would be bad, right? Just saying. Based on the information that we presented, does anyone have any comments or thoughts or questions, concerns to share before we sign off?
Yeah, question. I'm a Mac user, right? Does this still cater to me, right? Or would it be more tricky?
Yes. Are you an AAS campus student?
No, I'm on the OEK.
You're on OEK. Did you ever go to the computer lab in CAB building, in the CAB?
Yeah, I've been there.
Okay. What you can do is start working on this, and what we may do is call ITS to ask them to allow you to be an administrator on the machine so you can perform these tasks on a computer lab system. Is there anyone else in your family that has a Windows machine?
No, I stay on campus all by myself.
Okay, the roommate doesn't have, all right, never mind that. You don't want to get in your roommate's Kool-Aid. Let's start with the computer lab and send me an email saying you need better access to a computer lab system in CAB, and then I will reach out to the ITS department on St. Thomas, okay?
I have a question.
Yes.
Because I'm in the same boat as him. I have a Mac also. But I'm wondering if the library would be a better spot because the IT department is right there.
That's a great observation. And yeah, the short answer is you could. So now if the ITS staff says, yeah, nothing doing, we're not making you an administrator with your login on this library computer, there is a plan B. It's takes a little bit of doing, and you can do this solution with a virtual system that's running on a platform in my office. The trick is you got to be able to connect to it, and you're going to find that some of the things are different because what you're connecting to is a Windows Server system instead of a Windows 11 or 10. And there are going to be some slight differences, okay? I may have a virtual machine that's a Windows 10 or 11. I use it for a different class. Let's try the lab first, okay? And if that works, then we're good. If we don't have that, then we'll set up something in the cloud, okay? But what you want to do is check that out very quickly. So my advice would be get to the library or to ITS as soon as possible and send me that email, and I'll go ahead and request that for you. What you'll need to do though is make sure that you're on one machine in particular in the lab or in the library. And when they make that change and you're done with this solution, you'll have to put it back. Okay? Great question. Thank you for asking. Any other observations, comments, questions?